All right, let's just jump right in. We are going deep, deep inside the human body to unpack the incredible science behind one of its most underrated yet most powerful organs. So get ready, because we're about to hack the very code that runs your body's energy supply.
I mean, think about it for a second. What if a single biological command center could manage two totally different mission-critical systems? It sounds like something straight out of science fiction, right? Well, this isn't fiction. It is exactly what's happening inside you, right this very moment.
And the organ pulling all the strings? The pancreas. You know, for a long time, it was really just known for its role in digestion. But this is the story of its secret second life, a life that holds the absolute key to your metabolism. And it's a story whose secrets are completely revolutionizing modern medicine as we speak.
So to really get the pancreas, you've got to think of it like a double agent. The scientific term is a heterocrine gland, which is just a very fancy way of saying it has two completely distinct jobs. It's wearing two very different and very important hats.
But here's what is so mind-blowing about it. A whopping 98% of its mass, almost all of it, is dedicated to just one job: digestion. The story that we're chasing today, the one that controls your body's entire energy economy, well, all of that action happens within that tiny, incredibly powerful 2%. Let's break this double life down. So on one side, you have the exocrine function. Think of it like a factory, just pumping out digestive enzymes to break down your food. But on the other side, you have the endocrine function, the hormonal command center, making these tiny molecules that tell every single cell in your body how to use energy. Two jobs, one organ. It's pretty amazing.
Okay, so let's zoom in, way in on that critical 2%. Sprinkled all through the pancreas are about 1 million of these tiny little clusters of cells. These are called the islets of Langerhans, and you can think of them as the microscopic control centers that are running your entire metabolism.
Now, each one of these islets is like a bustling little neighborhood of specialized cells, all making different hormones. You've got delta cells, PP cells, even epsilon cells. But for our story, the two most important residents, the real superstars of the neighborhood, are the alpha cells and the beta cells.
These two cell types, alpha and beta, they're locked in this constant, really delicate dance. They make two hormones that have completely opposite jobs, and they work together in this perfect push and pull system to keep your blood sugar, your body's main fuel, perfectly, impeccably balanced.
Think of it like this. Insulin, which is made by those beta cells when your sugar is high, is kind of like the energy storage manager. It basically shouts to your cells, hey, we've got tons of fuel, store it for later. Then there's glucagon, made by the alpha cells when sugar gets low. It's the emergency energy releaser. It tells your liver, release the reserves, we need fuel, now. They are perfect, complementary opposites.
And the sheer elegance of this system is just on full display right here. It's a perfect cause and effect chain reaction. When your sugar levels go up, that glucose just flows into the beta cell, which creates more energy, which then flips a switch on the cell's surface, which opens a gate for calcium. And that rush of calcium is the final trigger that pushes insulin out into your blood. It is just a beautiful, beautiful piece of biological engineering.
So for decades, that was pretty much the story. Insulin lowers sugar, glucagon raises it. Simple, balanced, perfect. But what if that wasn't the whole story? What if one of these hormones was, hiding a secret?
This discovery right here, it completely changed everything. Scientists found that the way a hormone gets made depends not just on the gene itself, but on where in the body that gene is being read. See, different cells have different molecular scissors, these enzymes that chop up the raw protein blueprint into different final products.
And this is the plot twist. In the pancreas, the pro-glucagon gene gets snipped by one enzyme, PC2, to make glucagon. Simple enough. But in the intestine, the exact same gene gets snipped by a totally different enzyme, PC13. And what comes out is a completely different set of hormones, including a modern-day superstar, GLP-1. So, same blueprint, different factory, totally different products.
And GLP-1 isn't just another hormone. Oh no, it's a true system optimizer. It doesn't just blindly boost insulin. It's smart. It only does it when your sugar is high. It tells the alpha cells to cool it with the glucagon. It even slows down your stomach so you absorb things better.
And on top of all that, it sends a signal straight to your brain saying, hey, we're full. It's an incredibly intelligent, multi-talented molecule.
So we have this beautiful, intricate, and really intelligent system of checks and balances. But what happens when it starts to break down? This right here is fundamentally the story of type 2 diabetes.
With type 2 diabetes, it's like a triple threat breakdown. First, the body's cells, they become resistant. They just stop listening to insulin's message. Second, the beta cells get totally exhausted from trying to shout louder, and they eventually burn out, so insulin levels drop. And then, to make everything even worse, the alpha cells start releasing way too much glucagon, just pouring more sugar into a system that's already completely overloaded.
But here's the really inspiring part. Now that we finally understand this incredibly complex hormonal language that the pancreas and the gut are speaking to each other, well, we can start to speak it ourselves. And this understanding has led to some of the most revolutionary medical treatments of our lifetime.
And you can just see how our whole approach has evolved so dramatically. We started back in the 1920s by just replacing insulin. It was kind of a blunt instrument. Then in the 2000s, we got smarter. We learned to protect the GLP-1 our bodies were already making. By the 2010s, we were creating drugs that could mimic GLP-1 directly. And now we're entering an even more exciting era.
The latest breakthroughs are basically molecular Swiss Army knives. These are single molecules like tirzepatide and retatrutide designed to activate multiple hormone receptors all at once, mimicking GLP-1, GIP, even glucagon, to combine all their benefits into one superpowered therapy. And they're achieving results we've simply never seen before.
So when you put it all together, the takeaway is just profound. By decoding the secret life of the pancreas and its partner, the gut, we haven't just found better treatments for one disease. We've learned to speak the fundamental language of our own metabolism. And that just leaves us with this tantalizing question. Now that we're getting fluent, what other conversations are we going to be able to start with our own bodies?